So, what if a computer could explore every single possibility, all at the exact same time? Now, that's not science fiction. It's the reality of quantum computing. And today, we are going to break down how these absolutely revolutionary machines think and, why it's probably going to change everything.
Think about a game of chess for a second. Even the best supercomputer in the world is still just analyzing moves one after the other, just at an unbelievable speed. A quantum computer, though, it sees every possible move and every possible outcome all at once, simultaneously. This isn't just about being faster. It's a completely different way of solving the problem.
Right. So the key thing to get here is that quantum computers aren't just the next faster version of the laptop on your desk. Nope. They operate on the bizarre, kind of mind-bending, but incredibly powerful principles of quantum mechanics. It's like the difference between a player who sees one move ahead and one who sees the entire game all at once. Okay, imagine you're trying to solve a giant maze. A regular computer would try one path, hit a dead end, go all the way back, and then try another. It's methodical, sure, but it's slow. A quantum computer, well, it explores every single path at the same time. It finds the exit almost instantly. That's the power of thinking in parallel. So how in the world is this even possible? Well, it all comes down to the star of our show today, the quantum bit, or as we call it, the qubit. If a classical bit is like a reliable old light switch, the qubit is its magical, super-powered cousin. And understanding this one difference, well, it's the key to the whole shebang. A classical bit is super simple, right? It's like a light switch. It's either on, which is a 1, or it's off, which is a 0. That's it. But a qubit is more like a spinning coin. While that coin is in the air spinning, it's not heads or tails. It's in a state of being both at the same time. It's only when we stop it, when we measure it, that it lands on a definite 0 or 1. This whole both-at-once property has a name. It's called superposition. It is one of the weirdest but most powerful ideas in all of quantum physics. You've probably heard of Schrödinger's cat, right? Until you open that box, the cat is considered both alive and dead. A qubit is just like that. It exists in this mix of states until you look at it. And it's this amazing ability that lets a quantum computer explore all those maze paths at once. Now, if superposition wasn't strange enough for you, get ready for entanglement. Einstein himself called it spooky action at a distance. Imagine you have a pair of gloves. You put one in a box, and you send that box to the other side of the universe. The very instant you open your box and see a left-handed glove, you know instantly that the other one is a right-handed glove. Entangled qubits are linked in that exact same mysterious way. The state of one instantly tells you the state of the other, no matter how far apart they are. It basically breaks all the classical rules of space and time we thought we knew. So what happens when you put these two crazy properties together? This is where the power just explodes. With classical bits, your processing power grows in a straight line. It's linear. But with qubits, it grows exponentially. And to put that into perspective, just 300 entangled qubits can represent more possible states than there are atoms in the entire known universe. It's a completely different scale of computation, just mind-boggling. So with this kind of mind-bending exponential power, what can we actually do? This is where the theory becomes a world-changing application. We're moving from the how it works to the so what. And believe me, the potential is absolutely staggering. And that is exactly the right question to ask. See, quantum computers aren't for checking your email faster. They're designed to tackle a very specific class of problems, these massive, complex calculations that would take even our best supercomputers billions of years to figure out. And here are some of the really big ones. Quantum computers could break the encryption that protects our banking and our data. But on the flip side, they could also help us discover life-saving drugs by simulating molecules perfectly. They could help us design revolutionary new materials, untangle global supply chains, create far more accurate climate models, and completely supercharge the development of AI. But of course, if it were that easy, we'd all have quantum laptops by now. The reality is, harnessing this power is one of the greatest scientific challenges we have ever faced. The very same properties that make qubits so powerful also make them unbelievably delicate. The main challenge is this thing called decoherence. Even the slightest vibration, the tiniest change in temperature, or a stray electrical field can make a qubit just lose its quantum state and become totally useless. So to prevent this, quantum computers have to be kept in these hyper-isolated chambers, often colder than deep space. And even then, they need incredibly complex error correction just to work. But, despite these huge challenges, the race is on. We're in such a pivotal moment right now, moving from just theoretical physics to actual practical engineering. The smartest minds and the biggest companies on the planet are all racing to build stable, useful quantum computers. This journey, it didn't just happen overnight. It started way back as a theoretical idea in the 80s with physicists like the great Richard Feynman. Then it got a huge boost in 94 when Peter Shor's algorithm proved just how powerful they could be. And now, here in the 2020s, it is an all-out race to build them, with a really practical goal: creating hybrid systems that use both quantum and classical processors together in the next decade. Ultimately, this journey isn't just about building new machines. It's really about embracing a whole new way of thinking. It's about understanding that a problem can have many possible states at once, and then learning how to navigate that complexity. In a way, the future really does belong to those who can think in superpositions. Now that's the real quantum leap. The quantum revolution is really just getting started, so if your curiosity is sparked and you want to dive deeper, the source for today's explainer, Quantum Computing for Smart Preteens and Teens, is a fantastic place to continue your journey. Thanks for joining me.